Do what you got to do. Said do what you got to do. Ready to go? Okay, welcome back, everyone. I was kind of anticipating that it would be a small class today because people don't want to come to school when it's cold outside, so I appreciate that. I'll reward you today by giving you a quiz grade of 100 for everyone who's here today. So I won't give you a paper and pencil quiz or anything today. Because then I'll wind up having to give like 8 makeups or something like that. I don't want to do that. So you were almost going to miss it? Okay, well.
If there had been ice on my truck or I was just outside, I would have.
There was in my house this morning. There was ice on the steps. Doing what? You defrosted. I saw my neighbor out the other day about to pour hot water on their windshield. I was like, I actually don't care for them, so I was like, come on, break. Come on. No, I'm just kidding. Okay, so questions over the homework. Do we have any questions over the homework? 33. Okay, so we're looking at Chapter 2, Section 2, number 33. Oh, excellent. I'm glad you're asking. Okay, good. Not good that you had problems, but good that you're asking. Okay, we'll go through a few of these today. So before I begin this problem, let me make a little comment. You okay there? I'm gonna borrow this chair. Let me make a little comment about homework and getting help. In a class like this, I like to start class by answering questions, but I can't do 10 problems. I mean, we've seen these problems take a while, so I can't do like a bunch of problems. At some point, I have to cut it off. We have to move on. And as you go through to the next class, and especially you get to like college algebra, there's usually no time in class for going over homework. So if you ever have questions on homework, you want to try and get those things resolved before class. So try and do the homework the same day that we do the material. Like tonight's homework, try and knock it out tonight or tomorrow. Don't wait too long. And then if you have questions, take that time to try and get in touch with me. I'm just, trying to set you up for later on and what to expect. This problem, okay, is an excellent problem to demonstrate to you because I didn't really give you one like this. And there's something subtle here that if you don't do things the right way, you can get yourself into a lot of trouble. So we look at this, we see it's a linear equation, right? Our variable is to the first power, we have the equal sign. But we have a combination of decimals and grouping symbols, right? Both together in one problem. And because of that, we need to be careful how we approach it. Like, what do we do first? According to the steps, what goes first? According to the steps. Grouping symbols, right? Grouping symbols comes before clearing fractions and decimals. And that's the way that, to keep yourself from getting in trouble, that's the way you should do it here. Now, there is a way to do this by moving decimals first, but you've got to really be comfortable with decimals to do it. And it's all because of this parentheses. That parentheses causes a problem. If you try and move everything, if you try and move all the decimals right now, it's going to be wrong because of the parentheses. So just follow the steps. Remove grouping symbols. So how can I remove that parentheses? Multiply the 0.8 through to both of those terms inside. Now, someone in my other class asked me, do I have to put the 0 in front of the 0.8? No, you do not. If you want to write 0.8 by itself, that's okay. That's the same as 0.8. Books usually put the 0 in front just so you kind of go, wait, hold on. And then you notice that there's a decimal point. Sometimes you don't see the decimal point and you think it's an 8. So they put the 0 in there just kind of catch your attention, all right? I don't care what you do. All right, so maybe you need a calculator for this. You're going to do 0.8 times 2. 0.8 times 2 is 1.6. So you're going to get 6x plus 1.6x, and then multiplying the 0.8 times the negative, so it's going to be negative, 0.1, you multiply, you get 0.08. So I'm going to write 0.08. And then you have your distributions done, your equal sign, and then 151.92. Okay? Now you can start talking about decimals. I want to clear out my fractions and decimals. So my step 1 grouping symbols was done. Fractions and decimals is step 2. How many decimal places am I going to need to move here? 2. Because the 0.08 and the 151.92 both require 2 decimal places in order to make them integers, nice whole numbers. So that means everything has to get moved too, right? The 6 is really like a 6.00000, a bunch of them. And you just move it 2 places, 1, 2, and it becomes a what? 600x. Is that what you missed that part? Okay. The 1.6 is like 1.6000, and you move the decimal point 2 places, and it becomes a 160x. See that? Do you have questions on that? And then the 0.08, you move that 2 places, and it becomes what? 8. So minus 8. And then equals the 151.92. Move it 2 places, and it becomes 15,192. Is that all right? So step 2, removing decimals, is done. Step 3 is to collect like terms on both sides of the equation. Yeah, I can put the 600 and the 600x and 160x together to get 760x. And I keep the minus 8 there. And now I go on to step 4, which is to isolate or get by itself the variable term. So get that 760x by itself. So I have to get rid of that minus 8. So I do what? Add 8 to both sides of the equation. The fancy wording for that is using the addition property of equality. Add 8 to both sides. Same thing. All right. So 768 or 760x equals 15200, 15,200. If you want to put a little comma there for the 15,000, you can, but you don't have to put it. I usually don't. We've got step 4 done. Step 5 is to get rid of any number in front of x and make it a 1. So to get rid of 760x being multiplied, we divide both sides by 760, right? Okay. So divide by 760, divide by 760. And perhaps you need a calculator. You get what there? I think it's 20. You okay there like that? I mean, there's one right here too. But you need to drag the chair. Sorry. Excited to be here? Is that what you're saying? All right. All right. It's 20, right? All right. Now, checking the answer would be next. I'm sorry? Yes. Are you looking for your bonus? Is that what you're wanting there? You think that's worthy? I was giving people time to get here. Okay, well, remember I said I'd give bonus if I forget? Let's give me a window of time, okay? We'll say if I don't do it within the first half hour of class. But because I didn't say it, I'll give you a bonus for reminding me, okay? First half hour, though, all you're doing is reminding me. Thanks, appreciate it. But if it's after half an hour and I haven't done it, then you can get a bonus point, all right? I'll mark you down afterward. Remind me. Okay, well, I need to know your name, so. What's your name? Lisa, okay. All right, did that help? All right, what else? 53? So I was helping some students out in my office the other day, not in this class, but in one of my other classes, and we were doing solving linear equations like this. And you know how we have this set of steps, right? Well, I had these two particular students that had come in and were trying to work these problems, and they kept making the same mistakes. And it was always on the part where they were distributing through, like the 5 through or whatever here. And what they weren't writing down each step. Like they were trying to do it all in their head, and then they were trying to just kind of skip through steps. And I kept on telling them, do the steps, okay? Flip back in your notes, do the steps. If you can't do it flawlessly, then you have to rely on something else. And it was amazing because as much, I'm sitting right next to them trying to tell them to do the steps, and they still just were just not wanting to do the steps. The reason I'm telling you this is because if you struggle with any of this stuff, the process is what you need to learn. If you keep trying to do what you've been doing in the past and it keeps not working, Albert Einstein called that insanity. Okay, insanity is doing the same thing and expecting different results. Okay, you do the same thing over and over and expect every time you do it the same way, it's going to be different result. That's what Albert Einstein referred to as insanity. So, you know what I'm saying? If it hasn't been working out for you, the way you've been doing math hasn't been working out, try something new, all right? Just try it. See how it works for you. Get organized. All right, we have a linear equation here. I'm not saying those students were insane. I'm just saying, sharing a quote from Albert Einstein. All right, I'm going to remove parentheses first, right? Okay. So, sorry, I didn't put this. This was 53. So we have negative 1/2 x plus 5x minus 15 equals x minus 1. So I'm moving a little quicker through this, just trying to get us moving. Why did I not clear the fractions first? Because I have fractions here. You always remove grouping symbols first. So that's why I will do it, just not yet. Okay, so here we are. This equation, I've done the grouping symbols. I'm happy. Part 2 is to remove fractions. So I look around, I look for denominators, right? The only denominator I have is a 2. And so my LCD is 2. That's like the best case scenario. Well, best case would be no fractions, but the second to best case would be where you only have one denominator, in this case 2, and that means that forces it to be your LCD. So what do you do with your LCD once you find it? Multiply everything, right? Both sides of the equation. The way I write that is I do 2, my left side's pretty big, so I'm going to do big old parentheses, equals, and then 2 on the right side. And my right side, I also need parentheses. Why? What do I need parentheses on the right? Yeah, I have to multiply the x and the negative 1. So it's to help me see the distributive property there. 2 is going to go through both. On the left, here's what we got. So this was the step that those students I was helping, this is the step they refused to write. The 2 in front of everything on both sides. They were just trying to, they were looking off of this right here, and they were trying to do the 2 through in their head. And that, to me, is just, you know, if it works, you're good at that, good, fine. But if not, then you have to try and write things down. So I'm going to write one more step that I didn't write last time. I'm going to go and distribute this through piece by piece. I'm going to do 2 times that. That's 2, which is 2 over 1, times Negative 1/2 x. That's that first multiplication, isn't it? So I'm really showing detail now. Then I'm going to do the 2 times the 5x. That'll be plus 2 times 5x. Now, why did I write 2 on this one, and in the other one I wrote 2 over 1? Because it was a fraction, so I made the 2 a fraction. Here, I'm multiplying times 5x. I don't need it. Okay, next one. I need more colors. I have like plenty of colors here. I can go and get any color I want, but kind of gets to be a pain. Green, we'll do green. Green through here. This projector, can y'all tell the difference between those colors? I mean, there's different model projectors in different rooms, and some of them, like, the colors are great. This one's it all kind of blends together. All right, let's get back to this, sorry. What's 2, what am I going to do? Plus 2 times negative 15. I'm going to put it in parentheses like that. And then I don't have any more parentheses, right? That was another thing I noticed some people doing. Even after they distributed, they were still putting parentheses. You don't have them anymore. The other side of the equation, distribute through 2x minus 2. Right? All right, let's see what happens with this first red thing here. You can multiply straight across and get negative 2 over 2, which is negative 1. Agreed? So negative 1 in front of x is the same as negative x. The blue part becomes 10x, and the green part becomes minus 30. And then the other side, we had 2x minus 2. Any questions? So if you are happy and you feel good about going from that line to that line without showing that other part in the middle, that's okay. I'm just trying to help people out who might be having some issues with it. What's our next step? We've cleared the fractions. Step 2 is done. Like terms. Collect like terms. Good. So I'm going to collect my negative x and 10x together on the left. That gives me 9x minus 30 equals 2x minus 2. I can't do any collecting on the right. So my fourth step is to now get all my variable terms on one side by themselves. Well, I have x's on both sides, so I get to choose which side I want to go to. And I would hope that you would agree with me that the left side looks better, because I have 9 x's over there. On the other side, I have 2. So if I take away 2 x's on the right, it'll go away. I take away 2 x's on the left, and I'll have 7 x's, won't I? Now, I'm going to simultaneously get the numbers to the other side. So if my x's are going to go to the left, I'm going to get my numbers on the other side. So I need to get rid of the negative 30 on the left. How can I get rid of negative 30 on the left? Add 30. Now, if you want to do this in 2 separate steps, you can, or you can try and do it all together at one time. Let's see. What things cancel? What's gone? 30s are gone, and on the right, the 2 x's. So my new left side is how many x's? 7, and my new right side is 28. Fourth step's done. All my x terms are on the left. All my numbers are on the right. Fifth step is to get the number in front of x to be a 1. So divide by 7. Both sides, you get x is 4. That help? Who asked about that? Who was that? Who requested that problem? Is that okay now? Did you figure out what went wrong, perhaps? All right. I'll do one more. If anyone has a question over anything. No one had a problem with number 45? 4 or 5? You're going to do 45? Yeah. 51 is, yeah, that, you know what, my other class, they asked me about 51. If you go to the YouTube and you bring up that class's You know, like when you go to my YouTube, you can search through my playlist. If you go to their class, I did that problem. If you want to, you can go watch that. Yeah. 45? Okay. So number 45. Now, this is a good one. I was really thinking people were going to have questions about 45. X minus 3 over 3 plus x plus 2 over 4 equals 11 over 6. All right. There are two approaches to doing this problem. There's two ways to do it. In my class this morning, I did this problem for them, and I did it a certain way. I'm going to do it here in this class a different way. And that way, if this way doesn't make sense, you can go watch my other video from other classes if you want to and see it just a slightly different way. First of all, do we have grouping symbols? No. Technically, no. Okay, do we have, step one's done. Do we have fractions? Yes, we do have fractions. So what we need to do is look at the denominators and find an LCD. So the way I did that last time, I wrote out the denominators, 3, 4, 6. I started listing out multiples of those numbers. What are the multiples of 3? 3, 6, 9, 12, 15, forever. 4 is 4, 8, 12, 16, 20, forever. 6, 12, 18, forever, right? Those are my multiples of those numbers. What am I looking for here? The smallest number that's in all three of the lists at the same time. So 12, 12, and 12. 12 is the smallest number that appears in all the lists. So my LCD will be 12. Questions? LCD is 12. So what I'm going to do is bring my LCD in. Here's 12. My left side's pretty big, so there we go. Equals, here's my 12. And then my right side is only one thing, so I'm just going to put it like that. So on the left, I'm going to put x minus 3 over 3 plus x plus 2 over 4. Other side, 11 over 6. Is that all right? What makes this problem kind of weird is the fact that in our fractions on the left, we have two terms on the top. That's really not going to make too much of a difference when we multiply through. I'll show you how this is going to work. I'm going to go 12 times this first. So let me write that down. 12 over 1 times x minus 3 over 3, right? That's what I'm supposed to do? Let's keep our attention focused on that. We'll do the other distribution in a second. The 3 and the 12 reduce, right? How many times does 3 go into 12? 4. So there's really a 4 here, isn't there? Okay. I'll come back to that. Now let's do the distribution of the 12 through the next parentheses. So I have plus, again, 12 over 1 times x plus 2 over 4. This time, 4 goes into 4 once, 4 goes into 12 3 times. So I'll kind of highlight. I've got a 3 right here, got a 4 right there. And on the other side of the equation, I can do, oh, I should have put 12 over 1, shouldn't I have? Who cares? I'll put it now. On the right side, you know with me? 6 goes in 12 2 times. So I have a 2 left here. All right, now let's try and figure out what we have going on, all right? That 4 that's in the front, so I'm referring to that 4 right there. That 4 needs to multiply, see the little multiplication symbol, that dot? Needs to multiply times whatever was left on the top of the other one, which is x minus 3, right? So here's the way you should write it. 4 parentheses x minus 3. Because the 4 has to go to both. That make sense? Plus, what would the next one be then? 3 parentheses x plus 2. Good. And then on the other side of the equation equals, you have to do that 2 times the 11, don't you? Which is 22. So it's kind of weird because we started this problem, we didn't have grouping symbols. We cleared fractions, and now we have grouping symbols. So now we have to clear grouping symbols. So distribute through. We have 4x minus 12 plus 7x plus 6 equals 22. I'm just seeing if y'all are paying attention or not. Okay. All right. Now we can collect like terms. 7x minus 6 on the left equals 22. So I put my x's together there. I put my numbers together, and it gave me my 7x minus 6. What shall we do now? Add 6, so move 6. We're going to isolate the variable term by getting our negative 6 to go away. That'll leave us with a 7x on the left and a 28 on the right. Didn't we just have that a second ago? No. Was it? We did, right? And now I try and get that x to be by itself without a 7 in front, so do what? Divide by 7. So x is 4. So notice when I did this problem, I didn't start, I think I started writing the steps down, didn't I? And then I just kind of like totally went away from it. That's not because I wasn't doing them. It was just because I just didn't write them, okay? All right. Exciting stuff. So remember when I was telling you about paper, and we don't want to be, you know, maybe you'll be using a lot of paper, your hand will start cramping up. Are we talking about wasting paper in here? No? Don't worry about wasting paper, all right? I don't know if you know this, but our son, has anyone taken an astronomy class yet? Anyone ever taken an astronomy? It's really a good elective course if you're interested in things like this. Our sun is an average star, okay? I mean, everyone hopefully knows that our sun is a star, right? Just real close to us, all right. So our sun, if you look at all the stars out there that we can see, some of them are really big, some of them are really small, some of them are in between, some of them are really hot, some of them are actually cold, like dead stars. Our star is about average. We call it a main sequence star. And main sequence stars, what happens to them is they burn their fuel. Eventually, they run out of fuel. They start to collapse. They start to get smaller, and then they start to expand. And when I say expand, I don't mean like just like a little expansion. I mean, we're talking like here's us, okay? Like expanding to the point where it starts to eat up planets in its orbit. So when our star is getting close to its death, it will expand out, it will envelop a lot of things, and the temperature on Earth will become a temperature at which we won't be able to survive. So the Earth will at some point get recycled by our sun. And so you don't have to worry about the trees, you know. It's all going to get recycled. Everything's getting recycled. So, you know, there's different approaches. I know we won't be around for this. Hopefully. Well, no. We would see the signs already. It's not even close yet. But you know, there's certain schools of thought where, like, when you've seen all those blue recycle containers out there, right? Well, it's good for certain things, recycling. I think it's good. But think about those trucks that drive around and pick them up and all the pollution created by all those trucks. It's kind of a give and a take, right? You gain recycling, but you pollute the planet more by having all these trucks. There's been studies done like, is it even worth it to recycle because you're creating more pollution by trying to recycle? This is my theory on recycling. The ultimate recycling is happening at some point. For my wife, I take a blue container out, and I take the stuff out of the house. We have a recycled trash can, and we have a trash can. For the sake of my wife, I take both in separate, but once they get to the curb, they go out, same place. No, I'll separate them. No, I'll separate them. Yeah. All right. So take an astronomy class. Pretty interesting. Pretty interesting stuff. And I will stop myself because I will go on and on and on. Since you seem ready to move on, I'm going to go to chapter 5, section 1. All right, we're going to talk about integer exponents. Like before, when we were doing linear equations, I was asking you to understand what linear meant and what equations meant. Same thing here. I want to know what integer exponents means, and I'll help you out. But does anyone know what an integer is? What's an integer? Any ideas? Let's talk about that. Integer. All right, when you look at the evolution of human beings thinking, math started way back, and we had to at some point have the concept of numbers, right? And the first number that we ever started with was what? What do you think? The first number we ever understood? Actually, 0 came later. 0 was a huge accomplishment for us. Okay, the concept of nothing. 1 was first. So we had 1, and then 2 made sense, and then 3, and then we realized that we could keep counting forever, right? Those are integers, but there's more. There's also going the other direction, 0, and then we realized that there are actually negative numbers too. -1, -2, and then we could do that forever also. Those numbers on that list, going in both directions forever, are the integers. Somebody give me an example of a number that is not on that list. 3's on there. 0's on there. No, 0, when I'm talking about human beings, the first thing we ever, now I'm not going to get into an evolution versus creationism and all that here. What's that? That's right, but it came later. We understood that every number had an opposite number. And so the opposite of 1 is -1. What I was referring to is if you believe that there was a progression of learning, then, at the beginning when we were trying to, human beings started out nomadic, moving from place to place, but at some point we said, you know what, we can live off the land. So then we started saying, get the hell off my land. This is my land from here to here, and we started measuring. This is, I have one cow, I have 1 sheep. You know what I'm saying? We started measuring things. 1 was the first number, and then after that came the concept of nothing. That was, believe it or not, it was a huge jump, huge leap. That was like iPhones. It was like iPhones were born. The 0 was born. It was like that. So 0's on that list. What's not on the list? No, the ... means that it is. What's a number that's not on that list? Infinity is actually not a number. Infinity is an idea that it goes forever. So infinity is somewhat technically on this list because you can go infinitely out that direction, to the right and the left. Okay, okay, a fraction, like 1/2. Okay, 3/4. 0.3. So there are a lot of numbers that are not on that list. A lot of fractions aren't on this list. The integers are just these nice whole counting numbers and everything in between. Or not everything in between, and the negative numbers is what I meant to say. With me? Those are integers. So when we say we're going to study integer exponents, we're going to study those numbers combined with the idea of exponents, exponents. Any idea what an exponent is? Well, I'll help you with that. If I write something like x squared, I am assuming you have seen that before. What this means is x times x, right? That's what x squared means. Now, the x down here, we call that the base. And the power on the top here, the 2, is called the exponent. The power is the exponent. So what we're going to study for the remainder of today are powers that can be any integer, but not fractions. So we're not going to be studying things raised to the 1/2 or to the 0.3 or anything. Just something raised to any of those numbers on that list. What does it mean? All right? That's what we're going to do. All right, so let me help try and motivate the idea here with an example. If I write 2 with the 5 up there in the exponent, that means 2 times 2 times 2. How many of them? 5 multiplications. So having a power or an exponent just is a short way of telling you to do repeated multiplication. 2 times 2 times 2 times 2 times 2, 5 times. Right? That's what that means. And what is that number? 32? Agreed? What's 2 to the 4th? 2 times 2 times 2 times 2, that's 16. 2 to the 3rd? 8. Now I'm doing this because I want you to see a pattern. 2 to the 2nd is 4. 2 to the 1st is 2. And what's 2 to the 0? It's weird, right? Let's try and find a pattern. Let's look at this pattern. Let's start at 2 to the 5th. We had 32, right? When we took the power down 1, we went to 16, didn't we? 16 is half of 32, isn't it? So if we take the 32 and we divide it by 2, we get the 16, which is 1 less power. Now we reduce the power again and go from 2 to the 4th down to 2 cubed. We get 8, which is half of 16. We go down again and we take half of 8, we get 4. We take half of 4, we get 2. We take half of 2, we get 1. 2 to the 0 is 1. If you follow that pattern, do you agree that that follows the pattern? Now, it went 5, 4, 3, 2, 1, 0. What's the next integer if I keep doing this? -1. What do you think 2 to the -1 should be then? Follow the pattern. Follow the pattern. We started out 32. We took half was 16. Half of that was 8. Half of that was 4. Half of that was 2. Half of that was 1. What's half of 1? Or 1/2, right? Isn't it 1/2? And that is what 2 to the -1 is. 2 to the -1 is 1/2. It's not -2, because I'm not multiplying. It's not 2 times -1. It's 2 raised to the -1. And what it means is 1 over 2. What then do you think 2 to the -2 would mean? Keep following the pattern. You're going to do, this was half of 1 was half. What's half of a half? No? Half of a half. If you have a candy bar, you take half of it, and then half of that, it's 1/4. But couldn't you write it this way? 1 over 2 squared, which is the same as 1/4. I did that for a reason. You'll see it in a second. You can't have negative exponents. That's what I'm showing you. You can. What's 2 to the negative 3? What do you think? Well, it's half of a fourth, which is an eighth. But you could write it as 1 over 2 cubed, which is 1/8. Right? Because the bottom is 2 times 2 times 2. Then 1/16 would be next. And then I can say dot, dot, dot. It'll keep doing this. Do those numbers look familiar, though? Aren't those the same numbers we just had above? I'm going to zoom out just a little bit so we can see them. I need to zoom one more time. Sorry, it may be a little small, but look at 2 to the 5th is 32. 2 to the negative 5 is 1 over 32. It's its reciprocal. 2 to the 4th is 16. 2 to the negative 4 is 1/16. Got it? Now, I told you all my story about that. You know, I didn't start out as a math person, but now I'm 100% stamped math dork, right? I'll go sometimes to like the deli at H-E-B and I'll order half a pound of ham or something, and I'll ask them for 2 to the negative 1, 2 to the negative 1 pounds, just to see the look on their face. What's 2 to the negative 1? Half. So I'm saying half a pound. 2 to the negative 1 pounds, please. Half pound, never mind. But that's all it is. 2 to the negative 1 just creates a fraction. That's it. Do you follow that? Another way you can kind of look at it is the 2, like this 2 to the negative 2. All I did to go from that to the one on the right is change that negative to a positive, right? But dropped it below 1. And for those of you who've learned a little bit about negative exponents, you've been told if you ever have a negative exponent, just drop it to the bottom. Have you all heard that before? Just drop it to the bottom? That's essentially what that property is. Okay, your answers, and in this class and in this book, it'll say don't ever leave a negative exponent in your answer. You can have a negative exponent, it's just we like you to get rid of any negative exponents for your final answer. All right. While we're talking about 2's to powers, I want to bring something else up. What would 2 to the 6 be? 2 to the 5th was 32. 2 to the 6th will be 64. 2 to the 7th is 128. 2 to the 8th, 256. Does anybody recognize those numbers? Where do you see those numbers a lot? In computers, right? Right, 64 meg. Like when you buy your iPhone, right? Your iPhone is a what? Is it an 8 gig or 16 gig? 16 gig? 256, right? Okay, yeah, that's right. 64-bit, 128-bit. Have y'all seen that in computers a lot? You don't know what I'm talking about? It's okay. I mean, if you don't, it's all right. But these numbers appear a lot in computers. And the reason why they appear a lot is because they all have the same base of 2. And all a computer knows, that computer, this computer, your phone, all a computer knows is 2 conditions. It's either on or off. That's it. The computer is basically a bunch of on and off switches. And so if the only 2 states something can be in is on and off, then everything is a power of 2 to a computer, on or off. And so when they make memory, they have to do everything in powers of 2, which is why you always have 64, 128. You'll never go find an iPhone that has 20 gigabytes of memory. It'll be 16 or 32. Just a little random FYI useless information for you. All right, so let's now write down a formal property of property of these exponents. The property is as follows. X to the negative n really means 1 over x to the positive n. And if you need to, next to it, I'll write down to remind you, 2 to the negative 5 meant 1 over 2 to the positive 5. Right? That's what we did. So the x is like the 2, and the negative n is like the negative 5. So it just basically, you have to introduce that 1, that fraction, drop it down, write it on the bottom. No longer negative, it's now positive. Okay, let's do a couple of other things. That's the property, and we're going to use that on some examples. But I want to show you a very common example. I like to give things like this on the test. What's negative 4 squared versus negative 4 squared? One of these is 16, the other one is negative 16. So I'm just curious to know if you know which one it is. Negative 16 is without parentheses. The one with parentheses is 16. Okay, we'll do the one on the right first. When you square something, you mean multiply it times itself, right? So I'm going to take the negative 4. I'm going to multiply it times the negative 4 again. Negative times negative is positive, so I get 16. On the left one, this is the one that gets a lot of people, that negative in front of the 4 is actually not being affected by that 2. The 2 has no effect on the negative part. It only affects the 4. So that negative is by itself out front. So we really look at that negative in front as being like a negative 1 times a 4 squared. So if it's not in parentheses, the negative is separated. And if I write it like that, then order of operations, PEMDAS, right? Remember that? Says that I have to do the exponents before I do the multiplication. So I have to do the 4 squared first. And 4 squared is what? 16. 4 times 4 is 16. So what I'll get here is negative 1 times 16. And now you can do the multiplication. That's negative 16. Don't make that mistake on a test, okay? If the parentheses are there, it's whatever's there times itself. If the parentheses aren't there and there's a negative there, that negative just kind of hangs out in the front as a negative 1 the whole time, and at the end you pass it through. Okay? Be careful with that. All right, time to do a couple of problems. These problems are designed to kind of test some of the little subtleties of these things. I'm going to do a few, and then I'll try and let you do some too. Example, 4 to the negative 2. What I'd like for you to do is rewrite this without a negative exponent. Simplify it as much as you can. Don't want your answer to have a negative exponent. So doesn't that look like x to the negative n, something to a negative power? And according to our property, that's 1 over x to the positive n. So how could I rewrite 4 to the negative 2 as what? 1 over 4 to the positive 2. And what is 4 to the positive 2? 16. So this is 1/16. Box it, you're done. Next one. Questions though? Okay. The 4 is the x, right? The negative 2 is the negative n. The property tells us to rewrite it as 1 over whatever our x was, right? Here's our x. Our x was what? 4, so 1 over 4. And then that power that we had, but positive. So it became 1 over 4 to the positive 2 instead of 4 to the negative 2. Then I just squared the 4. What's 4 times 4? It's 16. So the bottom became a 16. The top stayed a 1. Okay? What about this one? Negative 5 to the negative 3. Does that look like our property? Something to a negative power? Yeah? No? Okay, what's the base? What's the base of this expression? -5. And since it's in parentheses, I consider the entire thing, right? That's my base. That's the x in the formula. What's the power? -3. According to the property, I can rewrite this as, it's automatic. You write 1 over, okay, always 1 over. And now you're going to rewrite it, but with the positive exponent on the bottom. So it'll be -5 in parentheses still to the third power, +3. You see that? Yes? Is that yes or no? You sure? Okay. Now what is -5 to the third power? It's -5 times -5 times -5. The first two, negative times negative is positive. So 25 times -5. That'll be a negative number. If you multiply them, you get 125. So -125. So what this turns out to be is 1 over -125. So the number -5, all of that raised to the -3 is the same as 1 over -125. All right, next one. Yes, you have to put the 1. If you just answered -125, it would be wrong. How about this? Before I start this, let me ask you this. What is 1 divided by 2/3? Is that the same as 1 times something? Remember, division is the same as multiplication, but you have to do what? Flip it. So isn't 1 divided by 2/3 the same as 1 times 3 over 2? And what's 1 times 3 over 2? 3 over 2. Okay? I'm just going to put here next to this recall. Okay, recall this. We're going to need it in just a second. Division is the same as multiplication of the reciprocal. So now here's the problem. How about 2/3 to the -1? What's 2/3 to the -1? Well, we have a base, don't we? Our base is 2/3. Our exponent is a negative exponent. And because of that, I can use this property. The property says I have to write equals 1 over, right? What? The 2/3, right? To what power? The positive one now, right? You want to follow that? But what is anything to the first power? Itself, right? It's itself. So isn't this 1 over 2/3? Yes? And what did I say up here a second ago? What's 1 divided by 2/3? That's what this says, right? What's 1 divided by 2/3? Well, what's 1 divided by 2/3, everyone? It's 3 over 2. So basically what happens is anytime you have 1 over a fraction, the fraction just flips. And it gives you 3 over 2. That's your answer, 3/2. So the only way to get good at these is to really sit down and just do problems and practice and start to see how the properties come out. You want to try a few? Yeah, that sounds great. Okay, let's do these. You'll work on these. Let's try and take maybe 5-10 minutes at the most. Try and do, and you're not going to turn these in. This is just for fun, if there's such thing. 3 to the -2. We'll call that problem 1. Problem 2. -2 to the -3. 3/4 to the -2. That's going to be a tough one. -7 to the -2. All right, see how you do on those. I'll turn the lights on and pause my video here. So if you want to, you can go back and look at the video, or remember I put these notes online also. You can just at least see how it's worked. Do you mind getting the light? So, oh, there you go. Can you hit the light coming in? I think it's the middle one. Yep, thank you. All right, our last topic for today is what's called the product rule. And I'm going to help you hopefully understand this rule by showing you an example. If I say 2 to the 4th power times, not plus, 2 to the 5th power, then doesn't that mean 2 times 2 times 2 times 2? That would be 2 to the 4th, wouldn't it? Then times 2 times 2 times 2 times 2 times 2, that would be to the 5th power, wouldn't it? But how many 2's are being multiplied together there, total? It's 4 off the first one and 5 off the second one. So isn't that 9? So isn't this the same as 2 to the 9th? How could you have gotten 2 to the 9th without going through all that middle step? Add up the 4 and the 5. That's what the product rule is. The product rule says if you have the same base, like these are both 2's, raised to powers, all you have to do is add up the powers. So here's the rule. Anything to a power times the same thing to a different power is equal to that to the sum of the powers. That's the product rule. That's your second formula for today. The other one was the x to the -n equals 1 over x to the n. Here's the second one. So let's do a couple of examples. What's 4 to the 3rd times 4 to the -5 equal to? That's 4 to the -2. Because what you're doing is you're saying they have the same base, right? And you have to pay attention to that. They have the same base, 4. So that's like the x. They have different powers. You just add the powers up. If you take 3 and you add -5, it's the same as taking away 5. So that's the same as 3 minus 5. It's 4 to -2. Now, would we leave our answer like that? No, because what's 4 to -2? 1 over 4 squared, and that's 1/16. So the answer is 1/16. Does that make sense? Okay. How about this example? X to the 5th times x to the 2nd times x to the 11th. What would that be? X to the 18th. Now, I gave you 3 of them, but that's okay. You can still do it. As long as they all have the same base and they're being multiplied together, you just add them up. So x to the 5 plus 2 plus 11, that's 5 to the x to the 18th. How about this? What's x to the 5th, y to the 5th? I'm trying to trick you. Warning. You cannot do anything to those, basically. Because why? They don't have the same base. If they don't have the same base, you can't add exponents. They have to have the same base. So for this one, and I'm not going to mess with you like that necessarily, but for this one, you wouldn't be able to do anything. So the answer would just be this. Okay? We just leave it. Just trying to trick you there. Could you do this? Can't do that. Different bases. Can't put them together. But can you tell me what that is? And even though you can't put those together using this property, is there still an answer to this? Yeah, this is 8 times 9, isn't it? 72. All right. You'll have an opportunity to work on that. So the homework, as I said, was on page 345, and it's 1 through 25 odd. So the reason I give you the odds first is why? Yeah, the answers are in the back of the book. So you get your confidence built up. You figure out, okay, I checked my answer, I'm good. The evens, you're not really going to know. Yeah, there's no evens back there. So, but that's where you can ask for help if you need. You can do them all together. No, you can do them all together. That's fine. Okay, I have one last thing. It's not on your notes, so you can kind of pack up, but at least show me a little bit of your attention. How many of you know what March Madness is? March Madness? College basketball, men's college basketball. Okay, tournament. Y'all familiar with that? Some of you? Okay, y'all know who Jimmy Buffett is? Yes. Have y'all heard about what he's doing? No. Okay, Jimmy Buffett came out a few weeks ago or days ago, I don't know, I just heard it on ESPN the other day. The way that the tournament works is that there's about 64 teams. This year is different, but there's 64 teams, and they get in this tournament, and they play games, and they find a champion, right? So what happens is you get the first 2 teams. I'll call it Team 1 and Team 2. They play each other. Whoever wins goes on. Team 3 and Team 4 play each other. Whoever wins, they play the winner of Team 1 and Team 2, right? Okay. Start with 64 teams. The first round has 32 games. Does that make sense? Right. 64 teams, 2 teams to a game. So the first round, round one, has 32 games. The next round would have how many games? 16 games. The next round would have 8. The next round would have 4 games. That's the final 4. The 5th round would have 2 games. And then your 6th and final round, 1 game for the championship. Okay. And here's the reason why I'm showing you this. Jimmy Buffett says that starting the tournament, you have the bracket. You know what teams are going to play, right? You know all 64 teams. The first 2 teams, you try and guess who's going to win. The next game, who's going to win. So you try and pick the winners of the first round. And then see who's going to win in the next round. And you fill out what's called your bracket. Y'all heard that before? You fill out your bracket. Jimmy Buffett says if you can fill out the bracket correctly, all the games, he will give you $1 billion. $1 billion. Yeah. Okay. So, well, here's why I'm showing this to you. Okay. Look at these numbers again. 32, 16, 8, 4, 2, and 1. Think about that last game. How many different ways could you guess who's going to win the championship? If you knew the 2 teams, this last game, that last game. How many ways could it work? It could be 2 ways, right? You could pick one of 2 ways. So there's 2 ways that you could do that, right? How many ways if there were 2 games? There's 4 ways, right? But isn't that 2 squared? Okay, if you have 4 games, it's actually 2 to the 4th number of ways. And then 8 games, 2 to the 8th, 2 to the 16th, 2 to the 32nd. That's how many different ways it takes to fill out each round. If you put these all together, it's 2 to the 63. If you just take a blank bracket and try and fill it out, and then your next one fill it out a little different, That's how many different brackets there that are possible. No, this is 9 with 18 zeros behind it. That's what that number is if you put it in your calculator. Uh, 3, 6, 9, 12, 15, 18. So we're talking about, this is millions, billions, trillions, gazillions, right? I mean, like, it's such a huge number that Jimmy Buffett's willing to say nobody's going to get it. And in the history of brackets, nobody has gotten better than just getting the first round correct. There's been one person, I think it was like 8 years ago, who got every game in the first round correct. And then the next round, it was over. No one's even gotten close to like their bracket being good down to the final four. No one's even got close because there are so many different ways it can happen that Jimmy Buffett's willing to put $1 billion on it. So, all right, yeah, you're better off with the lottery. These odds are astronomical. Y'all have a good day. Yeah, I'll see everyone on Thursday. Do your homework.